problem number 7 on the multiple choice asks which of the following is correct or are correct. So P, Q, and R are the 3 choices. I'm going to start out with P. So this question actually, all of it requires you to use knowledge from most of the sections that you've been through up to now. So you have getting common denominators, using or knowing what absolute value and square root, what they do to the number. We have a y to -1, so different things, and it's kind of all going to come together when we finish this problem. So for option P, we have 2 over x plus 5 over y equals 7 over x plus y. So what we want to do here is not solve for x or for y. What we want to do is just see if this side equals this side. So the first thing to notice is that the denominators for each one of these are different. So we can't compare anything here until we make all the denominators the same. So to do that, we can try to we can shoot for a denominator that's including all these 3. So x, y, x plus y. So this is the common denominator. So we want that on both sides. So we have x, y, x plus y. So to make this one have this denominator, we need to multiply the top by y and x plus y. So we have, let me make this bigger, 2y times x plus y. Now this one needs x plus y. So we have 5x, x plus y, and this one just needs xy. So we have 7 times x times y. So now that both of these denominators are the same, the only thing we really need to compare are the numerators. So we can stop worrying about writing down the denominators, and really we just want to see if that equals that. Don't move things over to the other side or anything like that, because really all you need to see is, does this equal 7xy or does it not? So I'm going to go ahead and let's see. Either we could take out x plus y from each one of these, factor that out, or we can multiply each of these out. So I'm going to go ahead and factor it out. Seems like less work. And so I'm left with just 2y plus 5x equals 7xy. So we can't really compare here yet. It seems like they're not going to equal, but let's go ahead and factor it in. So we have 2xy plus 5x squared. So I've done this. And now we have 2y squared plus 5xy equals 7xy. So here we have 2 that have xy's. So remember, if the variables are the same, you can add them. But since we have x squared, y squared, those are going to have to stay like that. There's nothing that we can add it to. So this plus this will give you 7xy plus 5x squared plus 2y squared equals 7xy. So just like our instinct told us before, now it's actually proved that these are not the same. Why? Because on this side we have 7y. And on this side we have 7y plus some other number. So this is going to be a positive number, and this is always going to be a positive number. See? So whatever is in here is added to the 7y that we have. So this side is always going to be more than that side, so it's not true. So P is not correct. Now we move on to Q. Q reads 3 plus y to the negative 1 divided by x equals 3 over xy. So the first thing to do here is, since we have a y to the negative 1, let's get rid of that ugly view and let's convert it into 1 minus y, or 1 over y. So y to the negative 1 equals 1 over y. Okay, so let's see what 3 plus y to the negative 1 equals at first. So 3 plus y to the negative 1 power will be 3 plus 1 over y, which now we can convert it into a common denominator. That way it'll be easier to plug it back in. So you see how I'm targeting these, both these problems are first making it seem simpler for me to see if they actually equal or not. To make it simpler, I've used common denominators and I've converted anything that has a negative power to its positive power version. So this, getting the common denominator of y, we get 3y plus 1. And now we can plug this back in here. So that becomes 3y plus 1 over y, and then this x on the bottom. Okay. You can also bring this x out and have 1 over x times this. You'll get the same solution. And then that will equal 3xy. So notice how here, you've already, without trying, you've got both sides to have the same denominator. So now you can start just comparing the numerators, since these are always going to be the same. So does 3y plus 1 equal 3? So the answer is no. This is 3y plus 1. This is just 3. So this is not the correct solution, and so Q is not right either. So, one more thing is, notice how both of these, I got the least common denominator, not only for the one side. So first you try to get it for one side, and then you try for both sides to have the same common denominator here and here. That way you can just compare the numerators. It makes it a lot simpler. So then lastly, this is a very quick proof. Basically, you need to know that for this to equal that, you would have had to assume that x squared plus y squared equals x squared, square root of x squared plus square root of y squared, which then converts to this. You see that? But we know from the definition from the lectures that this is not equal. So this is just a simple test to see if you know the definition of square root. So since these are not equal, then this does not equal absolute value of x plus absolute value of y. So this is not a solution either, and so the answer ends up being none, which is choice E. So choice E is your answer for this question.